Alright, y'all, this is the 6.4 notes over binomial expansion. So in this first section, it's asking us to expand the following binomials, then list the coefficients. So as a reminder, a binomial, that's just two terms, bi meaning two. So I have an A and a B, and that's two different terms. And I'm going to be putting these to different powers. So the first thing it's asking me to do is put it to the 0 power. Well, that's actually pretty easy because I know my exponent rules and I know that anything to the 0 power is just 1. Doesn't matter what A or B is, A plus B to the 0 is 1. So the only coefficient I see here is a 1. For the next one, A plus B to the first power. Well, anything to the first power is itself. So this would just be A plus B. The coefficient of A is 1, because remember there's an invisible 1 in front of that A. The coefficient of B is also 1. So I have two coefficients, I have a 1 and a 1. For A plus B squared, remember in order to do this, I have to do A plus B times A plus B, and then I would have to FOIL. So first A times A is A squared, outside AB, inside BA or AB, it means the same thing, and the last would be B squared. And then if I wanted to combine like terms, this AB plus this AB is 2AB. So we get A squared plus 2AB plus B squared. Our coefficients, that A squared has an invisible 1, AB has a 2, and B squared also has an invisible 1. Now, this little fancy thing right here is the beginning of something called Pascal's triangle. And in Pascal's triangle, each number is the sum of the two numbers above it. So 1 plus 1 adds to get 2. 1 plus 0 adds to get 1. My next row would be 1, 3, 3, 1, because that would be the sum of the two numbers above it. This pattern continues. There's a big old example of it here in this box. Again, it would go on forever and ever, but that gets us down to the 6th row. When we are expanding a binomial, because we are going to continue doing this, we can find our coefficients using Pascal's triangle. The pattern of the triangle continues infinitely. The exponents are also going to follow a pattern. So whatever the first term is, it is going to decrease. So this one, back up here, it started at A squared, and it decreased every time. So it went A squared, A to the first, A to the 0, which is just 1, and that's why it disappeared. The second term is going to increase. So this, in this example again, this started at 0, so it was B to the 0, which is why it didn't even show up, B to the first, B to the second. So knowing that information, here are the steps in order to write out a binomial. First thing you want to do is write out all the coefficients using that triangle. Then you want to write the first term with those descending exponents. Then your second term with ascending exponents, then simplify. So if I'm doing A plus B to the 5th power, let's follow those steps. Step number 1, we're going to write our exponents. So since we've got an exponent of 5, I'm going to go to the 5th row, and these are the numbers I'm going to write out. So I've got 1, 5, 10, 10, 5, 1. Step 2, write my first term with descending exponents. So my first term is A, and I'm going to start at the 5th and work my way down. So A to the 5th, A to the 4th, A to the 3rd, A to the 2nd, A to the 1st, A to the 0. Step 3, I'm going to take my second term, B. I'm going to start at 0 and work my way up. So B to the 0, B to the 1st, B squared, B3, B4, B5. And then I know that each of these terms is being added to each other. Awesome. Now all I have to do is simplify. Right? So like looking at this first term, I know I've got an A to the 5th, b to the 0, remember anything to the 0 is 1. So 1 times a to the 5th, I don't even have to write those 1s. That's just a to the 5th. Then we've got 5a to the 4th b. I don't have to put it to the first power because remember, if it doesn't say anything, we have that invisible 1. We already assume it's there. And then we've got 10a cubed b squared, 10a squared b cubed. No simplifying I can do on either of those. Plus 5a b to the 4th. I don't have to put the 1 above the a because it's implied if there's nothing written there. And then finally, 1 times b to the 5th is just b to the 5th. So that would be this binomial expanded to the 5th power. That's what we're going to be doing all day today. It's going to be fantastic. So let's follow those steps with these examples. I'm expanding the binomial. I'm to the 4th power. So first step, write out the coefficients. Let's look at our 4th row of our Pascal's triangle. 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Okay? Step 2, let's take our first term, putting it in descending order. So my first term in this case is x, and I'm going to start at the 4th and work my way down. X to the 4th, x to the 3rd, x squared, x to the 1st, x to the 0. Then I'm going to take my second term, step 3 says take my second term, and we're going to work our way up. So y to the 0, y to the 1st, y squared, y to the 3rd, y to the 4th. Now, all I've got to do is simplify. Y to the 0 is 1. 1 times x to the 4th is x to the 4th. 4x cubed y. I don't have to put the 1 above the y because remember it's implied. Plus 6x squared y squared plus 4x. Again, I don't have to put the 1. Y cubed plus, let's see, x to the 0 is 1. So 1 times y to the 4th is y to the 4th. That would be my answer for number 1. Okay? Number 2. This time we are looking at row 3 because our exponent is 3. Our third row, 1, 3, 3, 1. 1, 3, 3, 1. Okay, let's do our first term in descending order. X to the 3rd, x squared, x to the 1st, x to the 0. Let's take our second term. Let's go in ascending order. So 3 to the 0, 3 to the 1st, 3 squared, 3 to the 3rd. Now, we got to simplify. Let's put our plus signs in. Okay, so on our first term, remember anything to the 0 is 1. So this is 1. 1 times x to the 3rd is x to the 3rd. So far, so good. 3 to the 1st power is 3. 3 times 3 is 9, so this is going to be 9x squared. 3 to the 2nd power is 9. 9 times 3, 27x. And then x to the 0 is 1. 3 to the 3rd is 27, so 1 times 27, 27. That is our simplified answer on number 2. Okay, number 3. I'm going to get my 4th row. I found the 4th row on this one, so I know these are the coefficients I'm looking for. So I've got 1, 4, 6, 4, 1. Okay, first term, we're going to take this in descending order. X to the 4th, x to the 3rd, x squared, x to the 1st, x to the 0. Second term, we're going to ascend. So we're going to start at 0. We're going to do negative 2y to the 0, negative 2y to the 1st, negative 2y to the 2nd, negative 2y to the third, negative 2y to the fourth. Put in some plus signs. Time to simplify. Okay? Negative 2y to the 0 is 1, because anything to the 0 is 1. So 1 times x to the fourth is just x to the fourth. Okay? Negative 2y to the first power is negative 2y, right? Because anything to the first power is itself. So if I were to simplify, negative 2 times negative 4 would be negative 8, and then x cubed y, plus, let's see, let's square this first. Let's take another step at this. So 6x squared, and then let's square negative 2y squared. That would be, I would have to square each of these things. So negative 2 squared, negative 2 times negative 2 is positive 4, and y squared is y squared. So 4x, negative 2 to the third power, that means negative 2 times negative 2 times negative 2, that would be negative 8, y third. And then here, x to the 0 is 1, 1 times 1, negative 2y to the fourth, negative 2 to the fourth, negative 2 times negative 2 is 4, times 2 is negative 8, times negative 2 is positive 16. So 16 y to the fourth. All right, cool. Let's simplify a little bit more. Can't do anything with that one. You know what? I'm not going to put a plus. I'm going to put minus, since it's a negative number. There we go. Minus 8x cubed y. Here, I'm going to multiply that 6 and the 4 to get 24. 24x squared y squared. 4 times negative 8 would be negative 32. Negative 32 x y cubed plus 16 y to the fourth. There is my simplified answer. Remember, if you're not confident about any of these squarings or any about this multiplying, this is going to be a calculator test, so feel free to use your calculator to confirm on these. Okay, let's turn this over, keep going. Okay, so we're at the third row. What was our third row for Pascal's triangle? Third row is 1, 3, 3, 1. So I'm going to put my coefficients of 1, 3, 3, 1. Let's take our first term and let's descend. So we've got 3x to the third, 3x to the first, 3x squared. You know what, I'm going to erase that. I'm going to need a little bit more room. That's a big problem. Oops. One. Did I put, what did I do? Made a silly little mistake here with my exponents. Let's get that fixed. 3x to the third was first. Then it's 3x squared. Then 3x to the first. Then 3x to the 0. Now let's take our second term and ascend. So it's going to be negative 4x to the 0, negative 4x to the 1, negative 4x squared, negative 4x to the third. Each of these are being added up. Now I just got to simplify. Okay, so term number 1. Let's cube that 3x. So 3 to the third power, 3 times 3 is 9, times another 3 would be 27. That is 27x to the third. And negative 4x to the 0, well, that's just 1, because remember, anything to the 0 is 1. That's gone. Plus, let's do this one step at a time. Let's do 3. Let's square 3x squared. So 3 squared is 9x squared. And negative 4x to the first power is just negative 4x. Okay? Continuing on, 3 times 3x, because 3x to the 1 is just 3x, times negative 4x squared. So let's square each of those. Negative 4 times negative 4 would be positive 16x squared, plus, I don't have to write the 1 because that 1 times anything is just going to disappear. 3x to the 0, that's also 1. Anything to the 0 is 1. And I just need to do each of those to the third power. So negative 4 to the third power, negative 4 times negative 4 is positive 16. 16 times negative 4 is negative 64x to the third. Okay, one more step to simplify, and I think we'll have this problem done. 27x to the third plus, okay, 3 times 9 is 27 times negative 4. I think I'm going to let my calculator help me with that. 27, oh my gosh, 27 times negative 4 is negative 108. So, you know what? I don't want to put that plus sign. I'm going to subtract since it's minus. Negative 108, and then x squared times x is x to the third. Plus, okay, 3 times 3 is 9. 9 times 16, what is that? Let's see. Whoops. Come on. 144. 144, and then we've got an x and an x squared, so together that is x to the third. And then, oh, that's nice, our last one's already simplified. Minus 64x to the third. That would be our beautiful simplified answer for number 4. Okay, one more in this section, number 5, x squared plus 3 to the third. Okay, step 1, write out the coefficients. And it's 1, 3, 3, 1. Step 2, let's put our first term in descending order. X squared to the third, x squared to the second, x squared to the first, x squared to the 0. Now let's ascend our second term. 3 to the 0, 3 to the 1, 3 to the 2, 3 to the 3. Okay, let's simplify. X squared to the third. Whenever you have something to an exponent, you've got to multiply those numbers. So x to the 2 to the 3 would be x to the 6th. 1 times 1 times x to the 6th is x to the 6th. Okay, 3 to the 1 is 3 times 3 is 9. X to the second is x to the 4th, because again you have to multiply that 2 times 2. 3 squared is 9 times another 3 is 27. X to the second to the first, 2 times 1 is 2, so that would be x squared. And then finally, 3 to the third power is 27. X to the second to the 0 is 1, because anything to the 0 is 1, so it's just 27. That's our answer on number 5. Okay, so if I wanted to find a particular number in Pascal's triangle, there is a formula for that. And that formula is n factorial over n minus k factorial times k factorial, where n is the row you are looking for. Do notice, if you didn't already, on that front page, that first row was called row 0. And k is the term that you are looking for. Again, the first number is 0. So when it's asking us this, if you didn't want to use that formula, you really could do this the hard way. You could do that entire expansion like we just did on 1 through 5, or we could use that formula to help us find that one specific term. So if I want to find the coefficient of x to the third, well, that's going to be based on this first term, right? And since this is my first term, I know that's the one that's decreasing. So it's going to go x to the 4th, x to the 3rd, x squared, x1, x0. meaning I'm looking for the second term. So let's go back to Pascal's triangle. Let's look at the fourth row. And let's look at, so if this is the 0th number, let's look at that term 1, the first one there. So back to the triangle. Remember 0th row. Let's go down to our fourth row. We don't want this term, we want this term. 4 is going to be that coefficient. So I know I've got a 4. I know there's going to be an x to the third because this term was going to descend. It was going to start at x to the fourth, go down to x to the third. This term is going to ascend, right? So it's going to start at 5 to the 0. For this term, it would be at 5 to the 1. So this is also times 5 to the 1. Well, 5 to the 1 is 5. And if I were to simplify this, I'd have to multiply 4 times 5 to get 20 x to the third. So the second term of this whole thing is 20x to the third. The coefficient is 20. Our answer to number 6. I don't know why it says number 1. That's a typo. That's all right. Our answer is 20. Let's actually use the formula. So, again, the triangle is going to work for all of these. That would help. We could also use this formula. And the reason we have the formula and we don't just use the triangle every time is because, like, when we get down to this last one, I don't see the 15th row. So that's going to be really tough. So let me show you how this formula works. N is 4, because remember that is the row that I'm looking for. We went to the fourth row. And K is the it's going to be 1, because remember this was our 0th number, this was our first number. So K is 1. And if I were to put this into that formula, then that would be 4 factorial over 4 minus 1 factorial times 1 factorial. So to simplify this, let's take this one step at a time. 4 factorial over 3 factorial times 1 factorial. 1 factorial, that's just 1, right? So 3 factorial times 1 is just 3 factorial, so I don't even need to write that anymore. So I know I've just got 3 factorial on the bottom. In the top, I've got 4 factorial, which I could rewrite as 4 times 3 factorial, because remember that 3 would keep going and give me the 3 times 2 times 1 that I'm looking for. The reason I stopped at 3 is so that I can cancel those out. And I'm just left with 4. That works. So we found that using the triangle. We could also find that using the formula. Either of those methods will work. Just like I mentioned, sometimes one is going to be easier than the other depending on how big that number is. So on number 6, let's just use that formula. N is going to be 4 because that's the exponent. That's the row I'm looking for. K, if I'm looking for the third term, remember that first number is our 0th number, so really K is 2. So to plug this in, we'd have 4 factorial over 4 minus 1 factorial, 4 minus 2 factorial times 2 factorial. Which would be, let's simplify, 4 factorial over 2 factorial times 2 factorial. I know 4 factorial is the same thing as 4 times 3 times 2 factorial, which is helpful because now I can cancel out one of those 2 factorials. And it leaves me with 4 times 3 over 2 times 1, which would be 12 over 2, which is 6. So our next number in that pattern would be 6. So coefficient is 6. Okay, so if I'm looking for my third term, I know that this one was descending, right? So it started at 2x to the fourth, then it went to x to the third. For the third term, it is 2x squared. For this term, this one was ascending. So the first term, it was 2 to the 0. The second term was 2 to the 1. The third term is going to be 2 squared. Now let's simplify. So 6, I'm going to square both of these, so that's 4x squared, since 2 squared is 4. And that's also a 4, because I also need to square that too. 6 times 4 is 24, times another 4 is 96. Our answer is 96x squared. All right, last one. This one, I really want to use that formula, right? Because I don't want to have to draw the triangle all the way out to the 15th row. We don't have time for that. Let's use our formula. N is 15 because that is the exponent. K is, if I want the fifth term, remember I have to subtract 1 because that first term is 0. K is 4. So, to plug that in, that's going to be 15 factorial over 15 minus 4 factorial times 4 factorial. To simplify, 15 factorial over 9 factorial, 4 factorial. 15 factorial is 15 times 14 times 13 times 12. Oh, this is a lot. You know what? I'm going to show you how to put this in your calculator just like that. You all right with that? 15 factorial over 9 factorial, 4 factorial. So let's get that fraction first. 15, and then if I want factorial, I'm going to go to menu. I'm going to choose probability. It's my very first option. Then I got 9, menu, probability, factorial. 4, menu, probability, factorial. Wow, that's a really gross number, but that's what it is, 150, 150. Okay, so our coefficient based on the triangle is 150, 150. Let me rewrite that so that doesn't look like an 8. Maybe. You know what? I made a mistake. Whoops, let me go back and fix this because I said that 15 minus 4 was 9, and that's crazy talk. I'm sorry. 15 minus 4 is not 9. 15 minus 4 is 11. So it's still going to be a big number, but it's not going to be that big. let's try that instead. 15 menu probability factorial over 11 menu probability factorial for menu probability factorial. 1365. That's a lot more reasonable. Let's change that. So, according to our triangle, this number is 1365. Okay, now let's find those other terms. So if I've got the fifth term of the x, remember this is the one that's decreasing, so it started at 15, so 15, 14, 13, 12, 11, that's going to be x to the 11th. And if I've got the 3 is increasing, so it's going to start at 0, so 0, 1, 2, 3, 4. This is going to be x to the, I'm sorry, not x, 3. 3 to the 4th. All right, let's simplify. Let's try to simplify. 1365 times x to the 4th times 81, because 3 to the 4th is 81. Right? Let's make sure I didn't go crazy again. Yeah. So, we need to multiply 1365 times 81. And we get 110,565. 110,565, x to the fourth. That's our fifth term. That's our answer. I know that's not a 4, that's an 11. Can't read my own writing. Sorry about that, guys. That was an 11. This should also be an 11. So, yeah, these are some challenging problems. Be sure to write it out. Be sure you got a piece of paper or plenty of room to write. Take it slow because those simple mistakes are easy to make. Ask for help when you need it, guys. Good luck. You got this.